The U.S. power grid system suffers from several problems, from outdated equipment to challenges posed by extreme weather. But generating renewable energy close to the point of use with distributed generation helps solve several of these issues. Generating renewable energy close to the point of use with distributed generation can help the U.S. power grid cope with increased energy demands, meet environmental policy goals, and reduce the infrastructure needed to reach consumers. Distributed generation refers to producing electricity at or near where it is used. In this article, we will explore the importance of generating renewable energy close to the point of use with distributed generation. We will also discuss the challenges of this undertaking and the ways utility companies can increase their ability to provide renewable energy directly to consumers. Why it's important to generate renewable energy close to the point of use with distributed generation. Renewable and sustainable energy are similar, but not exactly the same things. They are both energy sources that don't require limited or finite fuel sources for the U.S. and world's electrical power supplies. Solar, hydrothermal, and wind power are all examples of these energy sources. Distributed generation refers to generating electricity at or near where it will be used. Although the U.S. has increased funding for renewable energy over the last few decades, only about 20% of the power produced in the U.S. comes from renewable sources. However, that number will rise in U.S. power generation from renewables is projected to increase from 21% in 2021 to 44% by 2050, according to the U.S. Energy Information Administration. These increased numbers for the production of renewable energy are likely to increase. This is especially true over the coming decade, as the U.S. government incentives encourage utility companies to adopt sustainable energy systems. But these renewable energy sources are less efficient when located in remote areas far from demand points. Distributed generation ensures that sustainable energy systems are near demand points like cities, industrial areas, or housing. By generating renewable energy close to the point of use, we reduce the need for new electrical transmission lines and improve the U.S. power grid sturdiness, as well as the following. Satisfies the increased demand for electricity, meets environmental policy goals, reduces the need for expensive infrastructure expansions. However, while there are many incentives and benefits related to installing and expanding renewable energy systems near demand points, there are also challenges that currently inhibit utility companies' ability to generate renewable energy near high-demand areas. Please see some of our other interesting articles on power, like long-term power blackout coming soon and what happens if the American power grid goes down. Challenges of generating renewable energy close to the point of use demand points through distributed generation. Despite the importance of generating renewable energy close to the point of use, ensuring that demand points have consistent access to this type of energy poses several challenges to utility companies. Some of the most notable challenges include the high expense of transitioning to renewable energy sources, conflicts caused by investor-owned utility companies, the physical limitations of installing renewable energy sources near demand points. Let's examine these challenges to understand their impacts on the ability of utility companies to generate renewable energy near demand points. The downside to corporate profits while transitioning to renewable energy and helping the average consumer. The precise amount of money it would cost to switch from petroleum and coal power plants to renewable energy systems varies, depending on the source. However, the Yale School of the Environment cites that the change to renewable energy would cost the U.S. an estimated $4.5 trillion. Although federally funded energy incentives can help offset the personal costs utility companies would need to foot for this change, the change would still be pricey. However, profitability may be the more imposing limitation for many investor-owned utility companies. After all, renewable energy costs far less over the long term, lowering the amount the average household would need to spend on electricity. While this change to renewable energy is a boon for the average consumer, it spells lower profits for utility companies. Unfortunately, this potential decline in profitability makes some utility companies unwilling to invest in renewable energy systems, even if those systems are integral to maintaining energy supply at demand points. The conflicts of investor-owned utility companies. If you've ever managed a business or a stock portfolio, you likely understand how crucial increased profitability is to the integrity of your business. For better or worse, several investor-owned utility companies that rely on fossil fuels to generate energy make sizable investments in coal, petroleum, and natural gas. These investments currently ensure that their companies remain profitable. Because of this, generating renewable energy would be a vote against the investor-owned utility companies and their own current investments in fossil fuels with the change of technology. These highly profitable, privately owned utility companies can also exercise significant political power because of their financial success. This fossil fuel utility lobbying consortium slows any potential progress toward creating renewable energy systems, especially near point-of-use high-demand areas. The physical limitations of generating energy close to demand points. The issue of physical limitations in generating renewable energy close to the point of use with distributed generation is big. It currently takes millions of miles of electrical power lines across the United States, according to the EPA and the U.S. Energy Information Administration, to get electricity to and through our cities and towns. Many renewable energy systems require plenty of open, uninhabited land to function at full capacity. For example, wind turbines are less efficient when installed near tall buildings, and industrial-sized solar panel systems can consume acres of land. So, although the concept of generating renewable energy near demand points is worth pursuing, the logistical aspects are complex and pose several challenges to engineers and utility companies. Fortunately, as renewable energy systems continue to improve and become more efficient, the physical limitations of producing green energy near the point of use with distributed generation may lessen. How utility companies can generate more renewable energy close to the point of use with distributed generation. Although there are significant challenges to generating renewable energy close to demand points, utility companies aren't without options. For example, by working closely with city planners, collaborating with automakers, and lobbying for increased infrastructure funding, utility companies can accelerate renewable energy projects aimed at providing energy near point of use with distributed generation. But how can these actions boost renewable energy availability in high-demand areas? Let's explore each option to find out. Utility companies can work closely with city planners. One of the initial challenges of generating renewable energy close to demand points is predicting where point-of-use areas will be located. This is especially true of developing towns and cities. However, by working closely with city engineers and planners who use current energy consumption data to calculate electricity usage estimates, utility companies can gain practical insight to help them narrow down the best possible installation locations for renewable energy systems. Collaborating with city officials and governments when designing future energy systems is also an excellent way for utility companies to offer input about upcoming city design changes. For example, utility companies looking to increase energy availability at current or prospective demand points could sway the decisions of city planners to allow for greater infrastructure to access that energy. This partnership benefits city planners, utility companies, and current consumers. Utility companies can collaborate with automakers and charging station companies. Apart from households and large office buildings, one of the most significant examples of a high-energy demand point is an electric vehicle charging station. Rapid charging stations can quickly drain the local grid of stored electricity, so ensuring that these stations have direct connections to high-producing renewable energy systems is vital to public utility companies, their customers, and the future of the EVs market. Consequently, the collaboration between automakers and utility companies is extremely practical and beneficial. Still, utility companies would likely need to persuade automakers to apportion some of the funding aimed at developing EVs to ensure that charging stations are near renewable energy sources. Please see some of our other articles on why the U.S. power grid isn't ready for electric cars and power rationing when everybody has electric cars. Utility companies can lobby for increased infrastructure funding and support. The Bipartisan Infrastructure Law has allocated more than $300 billion to infrastructure improvements, but many of these funds are primarily focused on improving roadways, bridges, and other highway projects. Although energy systems are also considered under the umbrella term infrastructure, utility companies might not receive a significant portion of the funds from this law. However, revamping the U.S. electrical grid systems is a costly process. This is especially true when transitioning away from fossil fuel energy sources and investing in renewable energy. For this reason, utility companies will need plenty of funding to generate sustainable energy at demand points. Lobbying for increased funding and federal aid is one of the most effective ways to ensure that the federal government's energy-conscious incentives and demands become a reality.